Raghavendra Dutti, so you can ask your friends to join.
Yes, sir.
Yes, sir.
Okay, I will start. Let them join. I'll stop that is fine. I can click this one. Sigma T we got it as minus 129.9 Newton per mm square. Now I should calculate resultant of sigma T and sigma N. Sigma R, sigma R is equal to root sigma N square plus sigma T square, which is equal to root of 125 square plus minus of 129.9 the whole square, or sigma R is equal to how much? 129.9, not 1299. How much? How much? How much?
180.27.
180.27 MPa or Newton per meter square. 180.27 is sigma R. Next, pi tan pi is equal to sigma, what we have done is the ratio of sigma T by sigma R. You can see from here, if I write like that, it is the ratio of opposite by adjacent sigma T by sigma R by, which is equal to sigma T by sigma R, sorry, sigma T by sigma N, or pi, which is equal to tan inverse sigma T by sigma N, which is equal to tan inverse sigma T x minus 129.9 by sigma N, it's 125. Tell me what is pi.
Minus 46.10.
Minus 46.1 degree. It means to say that if I have the body, if I have the um, body, the plate, plane like this, and if this is my sigma n, this is my sigma t. If I take this free body length to the right, sigma normal will be like this. This is normal. This is sigma t tangential, and the resultant minus 46.1 degree. It means to say the resultant is acting in the clockwise direction. From this point, this is from the explain. This is explain. This is explain. This is sigma normal. This is sigma t. This is at an angle 46.1 degree. This resultant is at an angle of 46.1 degree, and we can resolve this sigma t and sigma n. Okay. Sorry, I made a mistake. This is with respect to normal. The angle of obliquity, and the same angle of obliquity is with respect to this angle made by the resultant and the normal. Therefore, minus 46.1. It means to say that this resultant is at an angle of 46.1 degree with respect to my normal 46.1 degree. Okay, you can draw a tangential like this. This is t. This is sigma n. This is sigma t. Okay, no need to represent for understanding what I am telling you. This is normal. This is tangential. Next, fifth, sigma 1 is equal to sigma x, which is equal to how much? Sigma 1 is equal to sigma x. What is the value of sigma x? Sigma x is equal to 200. Sigma y is equal to minus 100. 200 MPa. Sigma 2 is equal to sigma y is equal to minus 100 MPa. Theta P1 obviously will be sigma x minus sigma y, which is equal to 200 minus of minus 100, which is equal to 300, is positive. Therefore, theta p is theta p1 only. If you want to write like that, you can write theta p is theta p1, or you can write directly theta p1 is equal to 0, and theta p2 will be 90 degree to that theta p2. And then sigma tangential is negative. Therefore, since sigma t is negative, it rotates s1 phase in clockwise direction. Okay. Now, in order to find the shear angles, maximum shear planes. Okay, what we can do? We can directly use the formula, or we'll stick on to the, since this is a biaxial stress. Since this is a biaxial stress, there is no much confusion, I think. Okay, I could have been used the same formula for this problem also. This is a biaxial stress, but I thought I can use the same convention what I have followed for plane stress condition. But you can also use that, but preferably you have to use this formula only. The angle is given by sigma. This tangential stress is given by, give me a moment. Yes, theta theta s1 is at an angle 45 degree, theta s2 is at an angle 135 degree. This is sigma t is equal to minus of sigma x minus sigma y by 2 sine 2 theta. You can directly use that. Okay. See, this is what we have got. Sigma t. Sigma t is minus of sigma x minus sigma y by sigma 2 into sine 2 theta. This will be maximum for 2 theta is equal to 90 degree, or theta s1 is equal to 45 degree. Okay, directly I can write like that. The you better follow this convention, this method only. But for plane stress condition, the method what I taught you holds good. Okay, the planes of maximum shear stress or theta s1 equal to 45 degree and theta s2 is equal to theta s1 plus 90, which is equal to 135 degree. Okay. Okay, this one the same. Rotating at an angle 45 degree and rotating at an angle 135 degree, S1 and S2, it remains the same. Okay. And if I want to represent schematic sketch, let me write x-axis, y-axis, obviously plane P1, P1, P2, P2, the faces sigma 1, sigma 2, sigma 2, sigma 1, sigma 1. What is the magnitude of sigma 1? It's 200 and minus 100. Sigma 1 is equal to 200. Sigma 2 will not be in this direction. Sigma 2. Sigma 2 will be in this direction. How much is that? Sigma 2, which is equal to minus 100. Minus 100. This will be also equal to sigma 2 is equal to minus 100. Sigma 1 is equal to 200. This is the principal plane. To plot the shear stress planes, xy plane, theta s1 is at an angle of 45 degree, counterclockwise is positive, perpendicular to 90 degree will be theta s2, x1, s2, s2, theta s1, 90 degree to that will be theta s2. If I draw the plane, the angle between S1 and S2 is 90 degree. If I draw the plane, I also have to calculate the average stress, sigma average. Directly from the formula I can write sigma x plus sigma y by 2. In this case, 200 minus 100, it's 50 MPa. 50 MPa. Since it is rotating sigma t is negative, it rotates. It's also of magnitude minus 129. It rotates the S1 phase in clockwise direction. This S1 phase, it will rotate S1 phase in clockwise direction. 129. Sigma average 50 MPa. 50 MPa. This sigma average. Sigma average tensile force. Sigma average. This is sigma average 50 MPa. Okay, I have understood better. We'll follow the same convention what you have done. I thought the same formula holds good for biaxial stress also, but this is better to stick on with the formulas which I have derived, okay, in the previous classes. So on the same, but it is a little tedious. Okay, and then other problem, the next type of problem is like this. If the problem remains the same, you will give a biaxial stress condition, and then you will make a last statement. What will be the intensity of stress which acting alone will produce the same maximum strain if Poisson's ratio is equal to 1 by 4? So in the if I replace this biaxial state of stress by a single magnitude stress, for example sigma x or sigma y, whatever single stress, okay, sigma, and it produces the same strain. Okay, what should be that magnitude of that stress is asking, that we have to find out. Okay, first, and that induces maximum strain. Okay, and it can be solved like this. First I will give The same thing remains here, but I will not calculate all the parameters, only what are we will calculate. My x is equal to 80, 80, sigma y which is equal to 40, 40. Now you have to tell me, now it is your turn, you have to tell me, this is vertical, write properly. This is making an angle 20 degree. What would be this angle? What would be that angle? What would be that angle? Alternate angle says 20 degree only. 20 degree. Okay? Since top down, sweeping the clock from 6 p.m. is towards the hypotenuse is in counterclockwise direction. Hence theta is equal to positive 20 degree counterclockwise. Okay. Next, before that, sigma x, sigma x is equal to 80, sigma y is equal to 40. We should sigma y is equal to 40. We should write that, and theta is equal to 20 degree. As usual, first sigma n is equal to sigma x plus sigma y by 2 plus is this audible now?
Yes, sir.
Okay, it's some internet problem. Plus sigma x minus sigma y by 2 into cos 2 theta, or I can write directly. Can you substitute and tell me sigma x which is equal to 80 plus 40 by 2 plus 80 minus 40 by 2, 40 by 2 cos 40. Tell me what is sigma n, sigma t which is equal to minus of sigma x minus sigma y by 2 into sin 2 theta, or which is equal to minus of 80 minus 40 by 2 into sin 40. Tell me what is sigma t. Sigma r which is equal to root sigma n square plus sigma t square. Therefore sigma r is equal to how much? Tan phi which is equal to sigma t by sigma r, or phi is equal to tan inverse sigma t by sigma t by sigma n, sigma t by sigma n. Tell me what is phi. Tell me what is sigma n.
75.32.
75.32 MPa. 75.32 MPa. Sigma t
Minus 12.855.
minus 12.8555 MPa. Sigma r. What about others? Sigma r How much? How much, Mekala? Dhruti?